Hello everyone, welcome to this next video in our series on problem solving with constructions in triangles. Today we're going to look at the first of 7 criteria, and today's criteria is the 2-to-1 angled triangle. That means I've got a triangle where the ratio of the base sides is 2-to-1. And we know from the last lesson in this that we learnt 3 techniques: drawing a cevian, completing a scalene triangle, and building from a side. In this video, or in this criteria, we're going to be focusing on drawing a cevian. And remember, the things that we're looking for are we're looking to create equilateral triangles, congruent triangles, a series of isosceles triangles, or maybe even that 30, 60, 90 triangle we've seen before. Alright, let's get started. So, what I want you to do, and please pause the video and have a go at this, construct an internal cevian, and you should know what a cevian is now, to make 2 isosceles triangles. So pause the video and have a go at it, and I'll wait for a moment. Okay, good. Hopefully you've paused it. So we're going to construct our triangle, our cevian, like this, and I'm going to make it such that this is 2x, these are equal, but we know if this is 2x and this is x, this external side here also must be x by the exterior angle of a triangle. So we can label this on as x, and you can see I've got x and x. Oh look, this is also isosceles. So what's so special about these 2x and x triangles is instead of just getting one isosceles triangle when we construct our cevian, we actually get 2. Okay, let's try another one. This time we're going to construct an external cevian and to make 2 rather than 1 isosceles triangle. I'll pause this and let you have a go at it first, and then I'll do the solution. So have a go at it now, please. Okay, good. Hopefully you've had a go. So I'm going to construct my external cevian out here and along to here. And I'm going to construct it such that this is x, meaning this and this are equal, but I know if this is x and this is 2x, then this has to be x as well, because x plus x must equal to 2x for that exterior angle. So x is here, but now look at this. This is x and this is x, so we know that this triangle here is also isosceles, and we get 2 isosceles triangles for the price of 1. Okay, this next example is going to show you that even though, and I didn't label my bases, so I'm just going to put these on very quickly, 3 theta and 2 theta, even though this triangle doesn't actually have that 2-to-1 base, we can do this cevian technique twice to make a 2-to-1 triangle. So the challenge is I want you to split this triangle into 3 isosceles triangles, and you'll have to do 2 cevians. So take a moment to do that. Okay, good. I hope you've had a go. So I'm going to start off by drawing a cevian down here like this, and I'm just going to go back a little bit. I want to get it fairly accurate, so there we go. That'll do. Now I'm going to say, alright, I know that this is 3 theta, and you can actually see I might even need it a little bit further, so let's just, I'll get it eventually, put it down here like this. Okay, that'll do. This is 3 theta, so this and this are equal. Now I know this is 2 theta and this is 3 theta, so that must make this angle in here theta for our exterior angle. 2 theta plus theta are 3 theta, and now look, we've made our 2-to-1 ratio triangle. So we can create our 2-to-1 ratio triangle from pretty much any ratio just by constructing a cevian ahead of time. Alright, let's now draw my second cevian on, And I hope you guys can see that we're going to be putting it up here like this, such that this is 2 theta, and I know now that this and this are equal. But looking at this, if this is theta and this is 2 theta, hopefully you guys can see that this here also has to be theta, because theta and theta is equal to 2 theta, and now I get another isosceles triangle here like this. So there you go, 1, 2, and 3 isosceles triangles, which we can use to build our congruent triangles, our equilateral triangles, our 30, 60, 90 triangles, or maybe just doing the angle sum in a bunch of isosceles triangles is enough to solve the tough problems we're going to get. Alright, so now you've seen the basic technique, let's try a few problems. So the first problem is we've got this shape here, and I'm just going to mark these sides as equal in case you can't see the equal marks, but I've got this side here is equal to this side here. This is 2 alpha, this is 60 minus alpha, this is alpha, and this is x, and we want to find x, okay? So the one we want to find I've marked in red is x. So let's do it. The first thing I notice is, well, and before I actually do this, please pause the video and you have a go at it yourselves, see if you can get the question out. Okay, good. I hope you've done it. So the first thing I notice is I've got a 2 alpha and an alpha here. So what I'm going to do is I'm going to construct my cevian as always, and let's make it a red line. So I construct my cevian like this, and there it is. Down it goes. What do you reckon, about there? Maybe about here? That looks okay, we'll leave it there. And we've now got our 2 alpha here, but because this is 2 alpha, this is alpha, I get another alpha up here. But let's look at what these combine to. 60 minus alpha and alpha, well, those just combine to 60. And better label my side. This is 2 alpha, this is alpha. So I know that this is equal. These two are equal because of the isosceles triangle. And I've got my alpha here and my alpha here. So these are equal because of this isosceles triangle. And you can see the technique now, right guys? We're getting all of those extra equal sides. So now I've got 4 equal sides floating around, which means I've got more isosceles triangles, congruent triangles, equilateral triangles potentially there. So let's take a look. Now I've got my 60 degrees and 2 equal sides, but two equal sides, or an isosceles triangle with 60 degrees in between them, that indicates I've got an equilateral triangle. Have a look. I join this to this, and I go, well, this is equal to this one and this one are equal, and this is 60, so that means this and this are equal because it's an isosceles triangle here and here. But if this is 60 and these are both equal, well, obviously this is 60 and this is 60, and because it's isosceles, this is equal as well. But now look at this, we've built a new isosceles triangle where this and this are equal. So let's just label this here as x plus alpha, and we know that because this and this have to be equal. So let's now solve it. We know that x plus alpha plus x plus alpha equals to 60 plus 2 alpha. I hope you can see why. This plus this is this. There's that exterior angle. So now I know 2x plus 2 alpha equals to 60 plus 2 alpha. Cancel our 2 alphas, and I've got 2x equals to 60 and x equals to 30 degrees, and I'm done. Okay, let's try a second example. So, as before, I want you guys to pause the video and have a go at it, and just make sure you can see these lines. This side here and this side here have been marked equal. So I've got x 22 degrees, 38 degrees, and 30 degrees, and of course we've got to find x. So pause the video, have a go at it, see if you can use this technique to solve this. Okay, I hope you've paused the video and had a go, so let's have a look at it together. The first thing I'm going to do is get a few extra angles. So I've got my 22 and my 30 here. So I now know that this angle up here must be 52. So I can say, okay, this angle, and I'm just going to put it in here. I'm just going to write a little arrow here though, so the rest of the writing doesn't get in the way, is 52. And this is 38. Now I know that this plus 38 must equal to the 52 for the exterior angle. If you wanted to work out this angle and then do the angle sum of this triangle, that's fine too. You'll get to the same answer. But hopefully when you do it, you work out that this is going to be 14 degrees. Oh, not 140 degrees. I said 114 degrees and wrote 140. So of course 14 degrees. Now I know that, well, this is isosceles, so this and this are the same because of the isosceles triangle. So that means this must be 14 degrees in here too. But now looking at this, I've got a 30 degrees and a 14 degrees. I combine that together and I've got 44 degrees. And here's my 2-to-1 triangle, 22 degrees, 44 degrees. So off we go. Construct our cevian like this and make it 44 degrees. So maybe that looks okay. And we know that this is 44 degrees because we've constructed it. This equals to this. Now I'm going to get this little angle in here. I'll just write it outside so I've got enough room. 22 degrees plus whatever this is equals to 44. So I know this has to be 22 degrees. There's that exterior angle again. So that's 22 degrees. And now this also gets a line on it because this is isosceles. Alright, so now let's take a look at this angle in here. 38 degrees and 22 degrees. That's going to combine to become 60 degrees. And this triangle here is isosceles with 60 degrees up the top. So when I draw this line here, I hope you can see, like before, we've got an equilateral triangle where we've got this is going to be 60 degrees. This combined one's going to be 60 degrees. And this is now equal, okay? Hopefully you saw that. That's 60 degrees here, and that's the 60-degree angle. That and that were equal, so these two had to be equal, and they had to be 60 degrees each. And of course we could work out this little bit here and this little bit here if we wanted to, but we might not need them. Okay, so now we've got our isosceles triangle here. Notice that this side here and this side here are equal. So let's label the base angles of our isosceles triangle, and I've got an x plus 22 degrees up here. And that's of course because this side and this side are equal, this angle and this angle are equal. And let's now solve it. We know x plus 22 plus x plus 22 equals to 60 plus 44. And you can see there it is. This plus this equals to this external angle of a triangle. Or if you wanted to, you could just work out this as being 76 degrees and then just done the angle sum of this triangle here if you preferred, and it would have been the exact same thing, only would have taken maybe one extra step. So now I know 2x plus 44 equals to 104, 2x equals to 60, and just the same as last time, x equals to 30 degrees. Okay, one more example with this technique. So as always, please pause the video and have a go at it to make sure that you can do it and that you've actually attempted it before just starting. Okay, or before just watching me do it. And before you start, I'm just going to show you that this and this side are the same. This side here is 40 degrees. This side here is 20 degrees. And this is x, just in case the writing was a bit too small. So please pause the video, have a go at this and see if you can solve it before just watching me. Okay, good. I assume that you've paused the video and had a go. So we're going to construct a cevian here, but this cevian I'm going to put on the outside like this, all the way over to here, and all the way back to here. And I know this is going to be, I started to write 20, but write x, but I wanted 20. And this is going to be 20, and I've constructed it so that this and this are 20. And now I can see I've got this side and this side the same. And looking at this, I've got this is 40, this is 20, so 20 plus this must equal to 40 because those are those exterior angles. So I know that this is 20 degrees as well. And let's now look at our triangles. I've got 20 between a 1 dashed line and a 2 dashed line, and a 20 between a 1 dashed line and a 2 dashed line. So these of course are congruent by our SAS test. And let's just shade in our congruent triangles there. 1 and 2. And since these are congruent, we know that this 20 here must match this x here. So x equals to 20 degrees, and in fact this triangle was isosceles all along, and so is this one. Okay guys, thanks very much. That's criteria 1 in our problem solving with constructions with triangles, our 2:1 ratioed angled triangle. Thank you very much, and I'll see you in the next video.